definitely not as practiced and polished a speaker as Ms. Harvey, and so if you can't hear me in the back, wave or throw something, please. Okay, here we're going to talk about a Pathfinder mission for the ROLSS Lunar Radio Astronomy Observatory. The team members at Goddard Space Flight Center are shown here. The activity takes place under the auspices and with some funding from the Lunar team of NLSI. Okay, so what is ROLSS? ROLSS is the Lunar Radio Observatory that is focused on solar observations. As you see here, there is one arm of something that could be capped on with something silver that could be antennas on it, as conceived by the artist. And there are two other arms going left and right. So it's a Y-shaped array, not dissimilar from those that you see on Earth. Solar radio bursts at frequencies below 30 megahertz have never been imaged, and at anything that you would call significant resolution. To do so requires an array of approximately 1 kilometer, and that was the purpose of the ROLSS concept as proposed to the Lunar Sortie Science Opportunity, LSSO, a few years ago. The PI of that concept proposal was Joseph Lazio. In that situation, a crewed rover was used, but this can certainly be done robotically. To the right are some artist conceptions of a larger array, which would necessarily be put on the far side of the moon to support imaging for cosmological purposes. Such an array would certainly require a Pathfinder activity. You can't put a $500 million array or even a more expensive array on the moon without something to precede it. So ROLSS, a smaller observatory, would also serve as a Pathfinder. Okay, on this complicated slide, let me just say a few things about more things about ROLSS, formerly the Radio Observatory for Lunar Sortie Science, which we have recast as the Radio Observatory on the lunar surface for solar studies. In particular, what we want to look at are radio bursts associated with coronal mass ejections and other solar activity. Some of the specific questions that ROLSS would be devoted to are here. Where does electron acceleration occur relative to shocks? Is it in the quasi-parallel region or the quasi-perpendicular region? In the case of so-called type 3 events, which should look like events from solar flares, but they're very intense, do they happen in front of the coronal mass ejection, or do they come from reconnection behind the coronal mass ejection, and so forth? I think I'll move on. Okay, so ROLSS itself needs a Pathfinder. We're still talking about a challenging thing to do on the moon, and so you want to do something that is manageable. Manageable means you deploy something from a lander, such as the Astrobotic lander shown here in this picture. I found this on the New York Times website this morning. It's too bad they couldn't have gotten the picture out here at Ames, but anyway, there it is. In general, most of the, I would say, of the Google X Prize landers would be very appropriate for a Pathfinder for ROLSS. Ideally, we would like to operate for more than half of a lunar rotation, but we'd be happy also if we had just 14 days. Who knows how that works? Oh, there it is. Okay. So the film that we would unroll schematically would look something like this. There would be a couple of arrays, and there are very big traces going back. In reality, they probably wouldn't be quite that big, but you can only do so much with PowerPoint. The goals then of the ROLSS Pathfinder is to validate film antennas like this, where you have metal capped on, and other components to measure the lunar ionospheric density, which you've heard about over the past day. I'll say a little more about it. Demonstrate observations of solar radio bursts if the sun cooperates. Test deployment with possible applications to larger missions, and specifically to serve as a Pathfinder for the ROLSS Observatory. So the key science for ROLSS Pathfinder, or ROLSS-P in this presentation, although someone will probably come up with a better name at some point, are first to look at the moon's photoelectron sheath, and especially the ionosphere in detail. You saw, but this can be approached from a variety of ways. It has proven difficult to say something conclusive about the ionosphere. It's been looked at by many spacecraft and other observations over time, and confusion still seems to reign. If we took a value something like 500 centimeters cubed per centimeter cube, which is similar to what was observed or purported to be observed by the Lunar spacecraft, this would correspond to an electron plasma frequency of about 200 kilohertz. For comparison, my source of all information, Bill Farrell, says that the daytime photoelectron sheath is on the order of 100 centimeters per centimeter cubed at the surface. So ROLSS, using a rheometric technique, will provide detailed, or rather ROLSS Pathfinder will provide detailed response to these questions. So what do we think ROLSS Pathfinder looks like? Here's another schematic. There's a canister mounted on the side of your lander. That canister contains a roll with film on it. There's some kind of anchor device sticking out of it. It would need a cover on it, of course, in real life, but if I put a cover on it, then you can't see it. So the deployment device opens and points the anchor in the proper direction, launches it outward, and it lands somewhere sufficiently far from the spacecraft and uses a line that runs through the anchor to pull out the film. It's a straightforward concept with a few things that could go wrong. For instance, you do need the anchor to hold in the regolith, and you certainly need for it not to tangle. And so those are some of the things that I'm playing around with in my spare time. In particular, the anchor that we would invoke would be something quite aggressive to catch on small objects, or if you had a glassine kind of surface, but it also needs to be a kind of a bucket to pick up loose debris that will hold it. And so to some extent, you would want to tailor that to the site once you knew what it was. But for the moment, a carbon fiber anchor like that is being developed for the purposes of general testing. Now, this looks quite different from what you were imagining, so don't hold your breath too long. At the Lunar Workshop in Boulder last fall, I showed some of the things that I was playing around with, and I've since called this the Adirondack lander. It's when you first start doing something new that's got a lot of complicated aspects to it, you want to try, as somebody earlier said, something simple. Well, this is kind of simple. It's your simple analog for a lunar lander in your backyard. And I'll just point out a couple of the things that are there. So there's the structural support that will support the deployer. The spring force is there. The antenna is, I deal with antennas a lot, but this is an anchor. The anchor is here. Its support is here. Monofilament was used as the line, but as the fishermen and women among you know, monofilament that's not under tension is a big mess, so that was a mistake. In fact, the line that is used is critically important, and I'm still dealing with that issue. This actually deploys paper towels, and the logic is if you can't deploy paper towels, well then you have a problem. But if you can deploy paper towels, then you can probably deploy Kapton, and so forth. So we needed to move on to something that looked a little more professional. But I mean, I still have a fondness for that Adirondack chair. But on this version of what we're attempting to do, there is a lightweight tripod with support for the antenna holder and spring force and a roll of something to be deployed and so forth. And the concept that had been being worked some time was to use the transmission from a remote control. A large remote-controlled toy, because that would allow it to be a wireless deployment. Unfortunately, I have to tell you that plastic gears just don't really work well, and so I've given up on that temporarily until I get a better transmission to use with a wireless controller. Meanwhile, the cordless drill was called into play, and so this is what it currently looks like: the wireless drill as the motor and the fishing reel as the pickup for the line. You can see it here in more detail. I highly recommend cable ties. You can do almost anything with cable ties, but we're not trying to use them for the lunar purpose. We're trying to use them so we can make changes quickly. And so part of the goal here is that this can be transported to show someone at another location. If I was a little further ahead, I might have been brave enough to bring it here, but that would be a little scary. Anyway, here's an example of what might happen. Or not. I'm sorry. I'm feeling. Yeah. What does it want now? Oh, I'm sorry. The Mac wants the cursor. I think it'll work this time. Maybe. I'll keep. Thank you, sir. Okay, so the anchor is being loaded, and off it goes with its double line, and then a little later we'll pull it back in. And find the cursor. Sorry, I just haven't figured out. There we go. I think that did it paused it. Oh, okay. Yeah, there are lots of things. Anyway, this works much better on more modern. All right, so now we're going to pull in the line, and I'm just doing this so you'll see it pull out the analog for a roll of Kapton. I've chopped a couple pieces out because you really don't want to look at or listen to this for very long. The next goal is to test this in other analog environments, because really the suburban lawn is really not a very good analog for the lunar surface. Plus, our neighbors are really bad at taking care of standing water. And this place is so full of mosquitoes that you might think that it's a cloudy day, but it's actually the mosquitoes hiding the sun. So, anyway, that's what you end up with after this exercise. I wanted, if I can, I wanted to show you what might happen with something with a little more power. Is that you can actually throw your anchor quite a ways. I'll do it one more time, maybe. So this is from last fall's lander, and so that throws it easily about 30 plus meters, or rather, excuse me, 30 plus feet, not meters. We're in English units here, but that still allows you to go quite a long ways. In fact, you may want to ask, how far should we go? I mean, could you remember that on the moon, this anchor that's in the air for a few seconds is going to be in the air much longer. So spring deployment seems feasible certainly for the Pathfinder. Oh, sorry, guys. For the Pathfinder, and we can avoid pyrotechnics for propulsion, which someone else might not like on their lander. We also, though, want to look at compressed gas as an alternative. But however you do it, if you were to use this anchor on the moon, it's going to hang up there for a long time, which made me understand why people have so much trouble moving around on that surface. In particular, if you fired it at 100 feet per second, which is extremely easy when you consider that a crossbow or a compound bow is something like 250 feet per second, you will throw it about half a kilometer. So we can work on the question: could ROLSS film be deployed using this technique? Obviously, the major obstacle is that obstruction or damage to film can certainly occur over the way as it's dragged across the lunar surface, unknown danger. There are ways to protect it by attaching scrim to the bottom of the Kapton. In conclusion, spring-initiated deployment of film antennas for a ROLSS Pathfinder mission seems feasible and will be investigated further. Thank you.
Thanks, Bob. Have you had any conversations yet with any of the Google X Prize teams about deploying on one of their early missions?
Right. I have started that process. Yes, there are so many of them.
That's true. There are. That's the good news. Other questions for Bob? Yes, Richard.
On spacecraft, deployable booms are fairly common, compact and automatically deployed. Could that not be a viable option that has some heritage?
Well,
or is there some complication?
You're saying I guess
If you
The
tied
analogy-
film to this
the
boom
analogy-
and let it deploy?
Let me take you way back here. If I can do it quickly enough. The main point is that in some sense of the word, we're looking for the preparation for a large lunar array for cosmological purposes. An array like this covers, in this artist's conception, 50 kilometers. And so the question is, given the mass of that, how do you keep the mass down? And I credit Dayton Jones for first thinking of this idea of just on the lunar surface having antennas deposited on Kapton, which is a very lightweight antenna capability. But if you have to get it out over this scale, covering a significant fraction of Tycho crater, for example, well, you're not going to throw it out, but you could,
right,
as part of ROLSS and ROLSS Pathfinder, you can test that variety of antenna. Thank you.
Unfortunately, I have to move on, so let's thank Bob again.